So am I visible? Okay, am I visible? I think okay. So if you have any voice problem, or like say if you don't see the screen, then please let me know. Okay. So let's first start. Okay. Okay, here you see what is the data set actually. So in the last class, I have taught you about some basic interaction with this Python syntax. Okay, so now today we will basically just will discuss how to this implemented this kind of ML algorithm in our dataset. Okay, so what is this dataset? So this dataset contains three classes of 50 instances each, where each class refer to a type of iris plant. One class is linearly separable from the other two, the latter not linearly separable from each other. Okay, so one of the dataset, one of the class, there are three classes of flowers is there. So iris plant is a kind of flower plant. Okay, so there are three different types of iris plant. Okay, so one class, let's say one class, this is called as iris setosa. Let's consider for this example sake. Okay, this is completely separable from the this both two. Okay, but in these two there is some intersection is there. Okay, sometimes you will thought that iris versicolor is virginica, and iris virginica is iris versicolor. Okay, so what are the attributes given? Attributes means you can say this columns. Okay, feature. So what are the features given? So first feature is sepal length. Okay, so what is sepal length? Just we search. Okay, so I am not from botany. Okay, so what is sepal length? Right. So sepal length means refers to a key measurement in botany, specifically in the identification and classification of plant. Is the length of sepals. Okay, this one. Okay, this is the sepal width and sepal length. This is the okay, and this is the petal length. Okay, and this is the petal width. Okay, I think this one is the sepal. Am I correct? Is anyone from the botany? Okay, I think I'm correct. Okay. Okay, let's say we have four these features are there. Okay, let's concentrate on that. So here some features are there: sepal length, sepal width, petal length, and petal width. And class is also given. Class means which class they belong to. Is it a iris setosa and iris? Okay, I'll just type. I also don't know which is which type. So these are types, separate types. Okay, so basically different type. Okay, this is some versicolor. I think this one is versicolor. Okay, different type of flower. Okay, so we'll not go into details, but you just imagine three different type of flower. Okay, but very similar in looking in display. Okay, so now first we have to import some module. Okay, so pandas last class I have discussed. So you have to import this pandas, then numpy, then this os. Okay, so then this matplot library is for plotting the graph. Okay, so you know about this. Okay, so first we will, you can, if you have any if you are doing, if you have any laptop, you can parallelly go along with me. Okay, just I will run here. Okay, run. Okay, so how to run? So you can just see control enter is there in here. You can directly type control enter. Okay, so it run. So if this number comes, okay, if it is running, then there will be star in here. If the number comes, then that means the execution done. Okay, so we have load this library. Okay, after that we will read the CSV file. So I have stored here in here. So this is the CSV file. Okay, so this is the CSV file I will open. Okay, so I will open. So panda, so PD means pandas. Okay, so last class I told you why we use panda. So because dictionary is competitionally accepts this kind of thing, so that's why we use pandas. Okay, so it will kind of store in array kind of form. Okay, so we'll read this CSV file and we'll store it as a value. So what is that? Data frames. We can call that as a data frames, or the variable we will take df. You can take other variable also, not a problem. Okay, for this example we will take df equal to pd. Pd means this pd panda, and read underscore csv. Okay, so if you type text, okay, then it will open a text file, but in here it is csv na, so we'll keep this as csv. So what is df head? Okay, if we remove this, run. Okay, it will run, but it will not show anything. Okay, so what is this df head command will do? It will display the first 5 rows. First 5 rows. Okay, all right, display the first 5 rows of the data set. Okay, first 5 rows of the data set. So if you run this, it will display these things. Okay, so here you can see sepal length is there and this sepal width is there. This all 4 parameters are there. You can say feature. In here it is saying attribute. You can say anything. Attribute, feature, these are same thing. Okay, so these are the feature of that flower. Okay, so we will displaying. Okay, so this is id. So some ids are assigned, like your roll number in your classroom. Okay, ids are assigned. So last class I told you that we don't need all the features for our model. Okay, so id will not tell you whether a plant is iris setosa or iris versicolor. Okay, id has nothing to do with that, so we have to delete that. Okay, so we need to delete this id. Okay, this id we have to delete. Okay, okay, am I audible? Am I audible? Am I audible? Okay.
Audible, sir.
Okay. Pace is okay, or do we have to go slow? Okay. If you in parallel you can do also. Okay. So now in here I will delete this ID column. Okay. How to delete the column? So in here you will see that this we will delete this column. Okay. So in here, so df is equal to df dot drop of columns is id. Okay, so if we in place of id, if we write like sepal length in centimeter, this is the header name. If we write in place of id, then this will delete this, but we don't want that. We just only this id we need to delete. Okay, so how to do that? So in here we will delete. Okay, we delete the dataset. We delete the this id column. In here you see id column we delete. Then we need to store it some in a variable, that table. In this tab, in the in this df variable, the ID is there. Okay, but if we store again after deleting the column ID, then what will happen? Then again I will show you. I'm just going control enter. Okay, so here you can see, so this ID is deleted. Okay, ID is deleted. Okay, so after that, now we'll have sepal length, sepal width, petal length, petal width in centimeters. So these are the only feature, four feature are there. Okay, on the basis of which we have to predict whether the species Iris setosa or Iris versicolor or Iris virginica. Okay, so that we have to predict using this sepal length and petal length. Okay, sepal sorry sepal length, sepal width, petal length, and petal width. Okay, so basically four feature are there. So now if we type this command, okay, df.describe, so what it will do, so it will display the statistics of about this data. So if I run this, okay, if I run this, so you can see here that count they will do 150. Actually, we have the data set of 150 flowers. Okay, 50 belonging to each clutch. So that means Iris setosa have 50, and then this all the three are have 50 each. Okay, so in here you see count is 150 and sepal width is 150. Okay, and petal length is also 150 and petal width is 150 because obviously 150 is there. But did you notice something? Yesterday I in the last class I have told you that is there any null value? No. If it has the null value, then the count will be different. Let's say some of the sepal width is not there. Okay, sepal width is not there, so then it is 140th for some flower. So that null values might be there. Okay, for that we have to check again, but from these count values we know that oh, okay, 150 plants are there, then everything is 150. So you can also see here mean is there, mean of the sepal length, mean of the sepal width, all the means are there. Then some standard deviation, these are the kind of some things are there. Okay, so what is the max count is there, mean count is also there. Okay, so this is the basic display, you can display the basics stats of a data. So basically if you have any Excel sheet, okay, if you have any data set, if you write this command, this will display this basic statistics of the data. Okay, okay, just run this. Okay, we got it. Then what is info about the data type? So what is df info? So data types means, so data types I told you, so it may be text, it may be number, it may be integer, it may be float means point. So 20.5, that is called float value, and as a whole number, let's say 4, it is an integer. So text, my name is a text. Then strings is there. Okay, so many types of data types are there. So how to check that which belong to which data type? So you just type and run this. So in here you just see here that 150 entries are there. So in computer science we always start from 0. Okay, so 0 to 149. So 150 values are there. So how many data columns are there? So you can see here 5 columns are there. So why 5 columns? 1, 2, 3, 4, 5. And this is not a column. Okay, this is just indexing. It will start from 0 and go up to 149. Okay, so then next in here you see this is the no non null, means not no null value is there. Then and float 64. So we are taking float 64 is the 64-bit number. Okay. So bit concept you just go through. So this is some floating number because 3.054. Why we did not take integer? Because it have point decimal. Okay. So point is there, so we'll take as a float. Okay. So in here we can see how many types of species are there. So each count how many actually that is saying. So if I run this, okay, if I run this, just wait. Okay, so if we run this, okay, then what we will get? So basically we will get iris setosa, how many iris setosa is there, how many iris versicolor is there, iris virginica is there, how many. Okay, so df uses right species and value counts. Okay, so you will get the know, you will get to know. Okay, so if we, let's say, if we type this one, okay, sepal length, what will happen? And type and done. So this will show. So 5.0, how many occurrence is there? So how many flowers have sepal length of 5 centimeter? Can you tell me? Can you tell me how many sepal length is there? So in here, how many 5.0? The sepal length is 5.0. So how many occurrence is there? You will see here 10 times. Okay. So 10 flowers are there that have the same exact sepal length of 5 centimeter. Did you got my point? So did you got my point? Please reply. So you got my point, I think. Okay. So please, if you don't understand the theory also, that also fine. But please try to understand the programming. Okay. So because in theory there are lots of maths are there. Okay. So you might get confused. But if you know how to do this coding, so you just call the function. I'll show you how to call the function. This um, let's say logistic regression. You don't need to write whole the program for the logistic regression. That somebody already had. Okay, they have written the code for logistic regression. Just you need to call the function. Okay, you just need to uh, bring the calculator. Okay, and you just type your value and that will calculate you. But in C programming you don't have that type of facility. You have to write it from the sketch. Okay, if I tell you to write the code for logistic regression, that you can write in also Python also, but it will be difficult for you because you are new for into the programming. Okay, so that's why data scientists generally use Python. Okay, so you don't have to write code for each model. Okay, so if you are using, let's say, knn, okay, so somebody written the code as knn and store it in some cloud and in some type of library, and you just need to call that library and that will do the your calculation. Okay, so in here you just see. So okay, sorry, now I'll go to spaces, just run here. Okay, you can see here 50 all the 50s are there. Okay, so now we have to do the pre-processing. So before going into the develop a model, so before testing a model, so we need to So we are not developing any model. We are just using our old model, ML models, that is already developed by someone, that is regression, logistic regression, that we will use. Three model I will show you in the next class. Sir will show different models. In here I will show you the three models. Okay, so in here we will say check. So df dot. So did you notice that I am always writing df dot, that you just note down. Okay, df, okay, data frame. So I'm just, so in here df, so the variable name is df. So we stored this table, okay, not this table, this table in df variable. So now we'll call df. Okay, so df dot is null. This is a kind of function. So what this is doing, so and sum we are using, if it is null value is there, so how many null value? Okay, so it will count, it will add all the null values and it will tell you. Okay, but there are not, no null value is there, so that will be all the sepal length centimeter is 0. This is telling that in this table, in this table, so I will physically open you this table. Okay, in here you just see. Okay, so not, no null value is there. Did you notice? Okay, not a single null value. Okay, not a single null value. Someone might ask question one, why it is 151? Because the first column is for the this ID sepal length, that's why. Okay, values are 150 only. So no, not a not a one null value is there. Okay, so we don't have to tackle that problem now. So now I'll go to the coding part. Okay, now we don't have the null value, so in here we just kept it like that. CSV file will kept it at like that. We will not do any modification, deletion, or this time the thing we will not do. Yesterday, in yesterday class, I have told you to delete or to make some mean or something like that, mean, median. Okay, we will not do that. Okay, now you are getting why I'm telling you yesterday these kind of things. So that's why the theory is sometimes important. Okay, so now let's go to next. So now I have to analyze the data. Okay, so how to analyze? So df, you know, the variable which I have stored the CSV file. Okay, that data set where I have stored the variable. So if you write histograms is a kind of you can call as a graph. Okay, histogram is a kind of a graph. Okay, so if we write df, this bracket, and we will mention this is the feature and dot histograms, what it will display. Can anybody tell me? Can anybody tell me? So I'll tell you. So in here just see, so 4.5. Okay, so how many flowers have 4.5 4.5 sepal length? There's like 8. Okay, 8 has 4.5. Then this is maybe like, I don't know, 3.3 or something like that. So all the distribution is there, all the distribution. Are you able to get the graph? Is there any question regarding this graph? So this y-axis is the number of counts, and this is the sepal length. Y-axis, sorry, y-axis is the count, x-axis is the sepal length. Did you got it? Anybody?
Sir,
Tell me.
sir, x-axis represents the count of number of iris species.
No. Number of count of feature. Sepal length is there. Sepal length centimeter is there. Okay. So how many sepal length will be there? 150. Total we are not considering now this species. Okay, let's say if you tell species, am I the car? I run this. So that is 3 only. Okay, up to 50, up to 50, 50, all the 50. Why it is? Because all species have 50. Okay, but in here we are just saying that 4.5 have like 8, around 8 counts. Did you got my point? Okay, I'll explain you it. Where it is upper length now. It is the count. So 5.0. So in here just you just see 5.0 is this one, na? 5.0. Okay. So what is 5.0? So it's saying 10. 10 count. So it's basically like that. 10 flowers. Not, don't consider this iris setosa, iris varnicosa, that we will not consider. Just consider 150 plants. Okay, we don't know the species. But 10 flowers have 5.0 centimeter petal length or sepal length. Okay, did you got my point? In here just we are checking the sepal length, so distribution of sepal length. So in here 0, 5, these are the counts. Okay, so if in this graph if we say that 5.0, so how many have like it's like it have 10, but this is very minor. Okay, this is a distribution we are showing. Okay, let's say 7.5. 5. Where is 7.5? Okay, 7.5 no 7.9 is there. 7.9. Okay, so 7.9 is like here. Okay, in here, but only one is there. Okay, only one is there, one count is there, so it's a kind of a just small variation. Okay, so did you got my point? Did you understand my this graph? So it's just showing the distribution of sepal length, so count, basically count. So I'll tell you, so I'll again explain you in the next. Okay, so if we run this, okay, in the sepal we will tell. Okay, let's run again. So in here you just see, so in here what we are considering, in here the number of counts 35, up to 35 it goes, and this is the length. Okay, this is the length. So 3.0, how many have like around like 35 or like 36, around 36, maybe something more. Okay, this amount of flowers, 35 flowers have sepal length of 3.0 centimeter. Okay, this is just we are showing it the distribution. In here is petal length. Okay, then here petal width. Okay, and here is the okay. So if you get if you are getting confusion, okay, leave it. It's just I am showing you the distribution. So how it is distributed among so how many counts are there, so how many 0.5 how many flowers are there that have the petal width of 0.5, that this graph is showing. Okay, so now I'll just, this is not an important thing, just I am showing you to how to do this histogram. Okay, if you remove this, this is no use actually for this in this case. Okay, so now we have to plot the graph. now we have to see the data set. Okay, so we'll assign some colors red, orange, blue. You can take any value. Okay, you can take hash value, this, I forgot the term. Okay, x value. Okay, hex. Okay, what that is called. Okay, if you got a color, then if you type color picker, you know this, I think. Okay, RGB value, sorry, this has hex value. Okay, you can put, if you move it like this, is the hash value of this color. Okay, this color. So you can pick any color. So if you want to pick, also you can check. Okay, or you can directly write the name of the color. Okay, we'll just basically take red, orange, blue. Okay, so iris virginica will be red, iris versicolor will be orange, and iris setosa will be blue. So but now we have to run this. Okay, then what we will do, we will plot this graph. Okay, so we will plot this graph basis of sepal length. On the basis of sepal length and sepal width, will also just, so in here sepal width is there, in here sepal length is there. So how the distributed this graph is. Okay, this might get you confused. Okay, so I run this program. Okay, so firstly I will assign, so blue means, what is this? Blue means iris setosa. In here you see iris setosa, iris versicolor is the orange one, iris virginica is the red one. In here we are declaring the colors of each species. Okay, so now in here, so we are writing a for loop. Okay, so up to 3, because we have only 3 species. So we'll just plot a scatter plot. Okay, x-axis will write as a sepal length, and y-axis will write, why it is writing x, it is written like this. Okay, but this will display on the y-axis. Okay, sepal width, and colors we have assigned. Okay, this is the colors and level and species. Okay, so plot x level, sepal length. So if we remove this also. Okay, so if we run, so it will run. Okay, so basically this is displaying the scattered graph of sepal length and sepal width. Okay, so this is a flower. Okay, this has a 5.0 sepal length, and it's around like 2.0 sepal width. Okay, so how to display that? So x-axis, why we are taking as a sepal length, that we are saying, and sepal width we are taking it as a y-axis. Okay, and we have to plot the legend. If we remove this, then what it will do? Just run. Okay, okay, sepal width come, but in here if you legend means, so which color denotes which. Okay, so it will come like this: iris virginica, iris versicolor, iris setosa. Okay, this is based on sepal length, sepal width. So how many combination will be possible? How many graph will be possible? 4 variables are there: sepal length, sepal width, petal length, petal width. So how many combination will be there? Okay, just you copy this code. Then again we will come from petal length and petal width. You just run this. Okay, in here it is not saturated. Okay, it here it's like, it's kind of means, um, what I mean to say, it is scattered, actually very scattered. But in here you see this iris setosa in on one side, then iris versicolor is on one side, and the red is on one side. So it is uniformly distributed, that you can say. In here you can say that it's very much scattered. So what I am able to say, what I am going to say, that what are the two features we are going to take to implement in the our algorithm. Did you got it? This petal length, petal width, on the basis of that, we can separate between these three flowers. So if the petal width and petal length is like say around 2 and 0.5, it will comes under iris setosa. If the petal width is like this 1 and petal length starting from 3 to up to I think 5, so it will comes under iris versicolor, and iris virginica will go from like 5 to up to 7. Some scattered plots are there, these plots are scattered, but we can see that this is very distinctly on the bottom side of the graph. Okay, so we will consider this point, but we have many other combination also. Now we'll go for sepal length and petal length. Okay, so this is the graph. It is also uniformly distributed, but this is kind of a scattered also. Okay, because not better than this. Okay, this is very better. But now again we will consider sepal length and petal width. Okay, so how many combination? One, two, three, four. So four combination is there. So why we got four? Can we go and get more? So actually four combinations are possible. Okay. So four combination are possible from two. So these are the combination we have noticed, and we all done in here. All if we run all these things, we'll notice that this is the most uniformly distributed is there, and in here petal length is there. So from this figure, we can say that from this petal width and petal length, we can check whether the flower is iris setosa. If it is iris setosa, we can directly say, let's say zero around 0 point, like it's here like 0.7, 0.7 petal width is 0.7, and petal length in between these things up to 2. So in between this, if petal length is up to 2 and petal width is up to 0.7, so we can say that this will belongs to iris setosa, because no other flower have this kind of petal length. Okay, but in here something might happen that this flower coinciding with this red dot. Okay, so we might get confusion between iris virginica and iris versicolor while we are looking. Okay, from the petal width we can directly say, okay, this is iris setosa. Okay, so other factors are not so good actually, so that's why we are considering this one. Okay, okay. Did you get my point now for this thing, the scattered plot?
Sir, I have confusions.
Tell me.
Sir, just now you have told so many features. I am not able to understand that how to analyze.
Okay. In here just you see how many feature. Four feature are there. Okay, four features:
Yes,
sepal
sir.
length, sepal width, petal length, petal width. So how can we compare? First we can compare between these two. Okay, we can take this is an x-axis, y-axis, and we can plot. Okay, so that will give us a like a scattered plot. Okay, so if we plot in a like a graph. Okay, Okay, this is some plotting. Okay, so in here we are considering sepal length. This is sepal, sorry, this is SL, sepal length, and this is sepal, what is that? Sepal width. Okay, sepal width. Okay, so let's say I have a flower. Okay, in here 5.1 and 3.5. Where I will put this flower? In here you go, you see the graph 3.5. No, 1, 2. I'm just writing as a rough. Okay, 4, 5, 1, 2, 3, 4. Okay, so now we'll take the first flower. Okay, 5.1 and 3.5. So length is 5.1. Okay, length, this is length 5.1. Up to this it will go na, and we'll check where it is. Our sepal width is 3.5. 3.5 is like this amount around this. So the point, the flower will reside in this point. Okay, okay, so did you got my point now? And again for the next element we will take 4.9 and 3.0.
Yes, sir. I am coming.
4.9 is 4.9 and 3.0 is will be like around this point. Okay, okay, so this will be and for we'll scattered 150 points. 150 points mean, okay, just don't confuse. We have a data set. Okay, we have a data set of 150 flowers. 150 flowers. So 150 flowers have each have 4 features. So if I give you a flower, let's say any flower, okay, so you will be able to see petal length, petal width, sepal length, and sepal width. Okay, so 4 features you will easily see. So that is the 4 feature for all 150. Did you got my point now? So on those feature, based upon those feature, we are just seeing that if we consider SL and SW, so how many combination will be there? So first we can consider sepal length, sepal width, then petal length, petal width, then sepal length, petal length, sepal width, petal width. Okay, so similarly we can do petal length, sepal 4 we just considering. Okay, did you got my point now?
Yes, sir.
Okay, now just we are making this graph. Okay, so if you go through the code, okay, after this class you will be able to explain. So I'll tell you. So I am using this graph. Okay, so sorry, Edge. So Edge is a co-pilot. Okay, so just you can, okay, if ChatGPT you can ask. So ChatGPT you just go. So if you have confusion, so explain this code. Explain the app. Oh, so he'll explain. So you got this point for loop, you know. So this says in iteration this line data frame they have to select rows where the species column is the species name from species list. You can see the all the explanation will be there. Okay. So and the x petal length represents the y coordinates petal length. So the arguments, this is the arguments. This will explain every point. Okay, this will display the lesion on the plot. This thing, all the things they will explain. If you have any confusion around this code, just explain. Just try to understand what I am going to do with this. Okay, so we'll got some plot. Okay, So now we'll make a correlation matrix. Okay, so what is a correlation matrix? So correlation matrix is a table, so showing correlation coefficient between variables. Each cell the table shows the correlation between two variables. The values is in the range of -1 to 1. If two values have high correlation, we can neglect one variable from those two. So yesterday I told you that some feature we can eliminate. So how to eliminate? So if it is the same kind of nature, okay, same kind of nature, then we can take one and we will remove the other. Okay, that's why we are using correlation. Okay, just run this. So we will see. So how many correlation we can plot this correlation matrix. Okay, so we will store this in a variable called chord. Okay, so now we will plot this variable. This is basically plotting. Okay, so we'll take this as a figure. 5 into 4 is the size of the figure. Okay, and heat map means this will make a kind of a heat map. So if we run this, okay, if we don't write this, okay, so if we run this, okay, so it will make this kind of color. Okay, it will make some kind of color. So why I writing this? A CMF color means if you write this, so if it is high correlation means red, negligible correlation means blue, and some medium level, that is dark blue, and orange is the is kind of not too high, it's a low. So that is for correlation. But in this data set we do not need to see it. We do not need to delete. Okay, we will not delete anything. Okay, but here you can see, okay, which have the high correlation. Okay, from here we can delete these things. So in here you can see that 0.96 is the highest. Okay, so petal length and petal length, why it is taking one, can you tell me? Why it is one? Petal length, and petal length is, this value is one. Why? So these are the same picture we are taking. If we are taking the same picture, correlation will be high, it will be one. Like I am taking, so I will ask you what is your height. In one graph height is given, like height is given. So if we compare height into height, the both column will be the same. Okay, so let's say you guys is a data set. So if you, each of you have a different feature, one of the feature is height, weight. Okay, if I compare height, I'll take one height of all the people, and on the left side, on the right side, I will again take height. So if I compare those two, so what will be the correlation? So it will be high because matching na. So if we consider, let's say, did you get my point? In here height is there, so someone height is 4 centimeter, so x height is x 4 centimeter, his other column height will be 4 centimeter. Okay, so same only. So that's why it has the highest correlation. Okay, that's why its value is 1. So what is the highest correlation of other than these things? So we have petal length and petal width. Okay, so petal and length and petal width have the high correlation. So these are kind of a similar, okay, very similar kind of values. Okay, not similar, total similar, very similar. Okay, so not ditto similar actually. So now let's leave it. Okay, this we will not correlation matrix here also. Just you, we have to use if you have many kind of feature. Okay, but in here we will not use. Okay, now what is level encoder? So in machine learning, we usually deal with dataset which contains multiple levels in one or more than one columns. These levels can be in the form of words or numbers. Level encoding refers to converting the levels into numeric form as to convert it from machine readable form. Okay, just ignore these lines. Okay, it's boring. So I'll tell you. So in here, just you see. So in here, all these things are in numbers. In here, you just see all the things are in numbers, but the spaces have like text. Iris setosa, iris setosa. These are all text. So what we will do, we will just convert this iris setosa. We will consider it 0. Then again, we will consider iris versicolor as 1. Then iris virginica I will consider as 2. So 0, 1, 2. So this is kind of converting these text to some numeric value. Okay, it is in text value. We will consider it as a numeric value. So here we will just will take from SQL learning processing. This is the library. So we will import this level encoder, and LE will level encoder put in LE. So we'll just call this fit transform, species will transform. Okay, so if we run this, okay, this will run. So in df species, okay, this is the species will confirm, will transform. Okay, we will transform here. So species, he will automatically convert something to 0 and something to 1. Okay, and something to 2. So if we run this, so you can see here. So now if we are displaying df8, now in here you species, you can see the 0. So previously what is it? It is iris setosa. So we know that iris setosa, he is declaring as what is 0. Okay, tell me in here why we are not manually taking, let's say iris setosa we are declaring as 1, iris versicolor is declaring 1, iris virginica will declare as 3. So why we are not doing it manually? We are calling a package to transfer to transform these spaces into some numeric value. Why we are doing that? Can you tell me, somebody? We are using level encoder. So we can define a species. Let's say this iris setosa will be called as 0, iris vanizuka will be called as 0, okay, 1, and the third one is the second. So why we are not doing that? We are calling this. Can you tell me?
If sir, we if you do it manually, then it will take lots of time.
Okay, because this is a small data set. For this you can do, but if it is a big data set, okay, then how can you do? So it will take more time. Okay, so that for that, it's doing. We are using the help of this level encoder. Okay, now we have done. Just we are converting it to 0 and 1. Okay, now main important part. So now we have to train the model. So from sklearn, so it's a package. Okay, sklearn is the package. So this is a from sklearn dot model selection. Okay, model selection import train test split. So what is this function train test split? So train test split is a kind of a function which will randomly split the your data set into train and test basis of your input. So if you want test data sets to be 30%, that it will go 30% and 70% to training. Okay, so in here we are considering train 70, test 30. Okay, so x is, so we have to drop the column spaces. Why? Because we want to predict species. Okay, based upon this 4 feature. Okay, based upon this 4 feature, so we are going to predict species. So that's why we have to drop the species column. Did you get my point? We are dropping the species. Is there any question? There might be question some. where we are dropping the species column. In here, df drop column species. We are dropping the species column. So because we don't want to feed the model that what is the species that belongs to, it will be too easy for the model. So if you know he knows the species, he can directly tell, oh, by looking at the data. So by training, we are just giving these 4 feature only. So we'll just drop this data set and we'll put it as a in some other variable, let's say y. Okay, the species will be, this will be the y, will be the output, y will be the output, x will be the input. We will not take species as a input. Did you get my point? Why we are not taking species as a input? Because we want to predict species. Okay.
Then sir,
Did you
from where it will show that this particular means having better length
okay,
and
actually from this feature, 4 feature.
okay.
Okay, so I will give you a data set. Okay, so I will give you a CSV file. I will tell you from this, I'll give you a flower, and flower you have to identify whether it is iris setosa, iris vernacular, or this kind of thing. So what you will do, so you will just see, and you just will measure the length, all the things, and you will just check CSV file that, oh, it is belong to 1, value is given 1, or it is written as iris setosa. You will not bother about this. You will directly tell, oh, okay, is iris setosa, just by looking at this petal length, petal width, sepal width, and sepal length. By looking at this, oh, this is belonging to this class, iris setosa. Okay, so you will kind of sit. You will kind of sit because you are seeing the species. So that's why we will hide the species from our machine. So we will not tell. We only tell this based on this figure. So everybody, I think I understand Assamese, so I'll tell you in Assamese also.
Okay sir.
তোমাক মই ফুল এপাহ দিলোঁ, ফুলপাহ চাই পেলাই মই তোমাক ক'বলৈ ক'লোঁ যে কি ফুল হয়, নাৰ্জী ফুল বা যি ফুলেই নহওক, তুমি চৰি নাৰ্জী ফুল হ'লে বেলেগ হ'ব, কাৰণ শ্বেপটো কালাৰটো চাই গম পালা। চ' ইয়াত চেপেল লেংথ, চেপেল উইথ, পেটেল লেংথ আৰু পেটেল উইথ আছে। অ'কে, চ' এইকেইটা এটা ফিচাৰ হয়। তোমাক মই চাই পেলাই ক'বলৈ গ'লো যে এইটো কি ফুল হয়, তুমি ক'লা যে এইকেইটা চালা, এইকেইটা চাই পেলাই তুমি CSV ফাইলটোত চালা যে অ' এইটো ঠিক আছে, এইটো এইটো ক্লাছত বিলং কৰে। তুমি ডাইৰেক্ট মোক কৈ দিলা, তুমি একো ট্ৰেইনে নকৰিলা মডেলটো, তুমি এই ডাটাখিনি লৈ একো ইণ্টাৰেষ্টে নহয়, তুমি এইখিনি চাই প্ৰেডিক্ট কৰিব ট্ৰাই কৰা নাই। তুমি এনেকুৱা এটা পেটাৰ্ণ বিচাৰিব লাগিব যোনটো চাই, এইকেইটা ডাটা চাই তুমি ক'ব লাগিব যে তোমাক মই যদি পেটেল লেংথ, চেপেল লেংথ গোটেইকেইটা দি দিওঁ, 4টা ফিচাৰ দি দিওঁ, তেতিয়া তুমি মোক ক'ব পাৰিব লাগিব যে চেপেল লেংথ স্পেচিছটো কি হয়। এইকেইটা তোমাৰ এতিয়া আছে কাৰণে তোমাক মই আননন ভেলু কিছুমান দিলোঁ, যোনবোৰ ইয়াত নাই ডাটা ছেটটোত নাই, তেতিয়া সেইটো কেনেকৈ প্ৰেডিক্ট কৰিব। সেইটো কাৰণে আমি ইহঁতক স্পেচিছটো নিদিওঁ। অ'কে, চ' ডেটছ ৱাই উই হেভ ডিলিটেড দ্য
আচ্ছা স্যার,
স্পেচিছ।
তাৰমানে এই এই যোনটো আমি ট্ৰেইনিং সেটটো দি আছো, আমি এইটো খালি পাছ কৰি আছো এজ এ পেৰামিটাৰ, আৰু মানে ফাইন কৰিব CSV ফাইলৰ পৰা, হয় নেকি স্যাৰ? আচ্ছা আচ্ছা
ফাইনটো CSV ফাইলৰ পৰা নকৰে, মানে জাষ্ট আমি CSV ফাইলটোৰ পৰা ডিলিট কৰাই দিছোঁ বৰ্তমানৰ কাৰণে।
আচ্ছা, তেতিয়াহ'লে
অ'কে,
কেনেকে? আচ্ছা
ৰ'বা মই কৈ আছোঁ, তাৰপিছত তোমাৰ এইটো ডিলিট কৰাটো ঠিক আছে। অ'কে, আফটাৰ ডিলিটিং দ্য স্পেচিছ, অ'কে, নাও উইল হেভ টু ষ্ট'ৰ this row as somewhere, so we'll store is a y, so that is y is output and x is input. Okay, so in here just you see x train x test, y train y test. So we are taking also, we are feeding output also and input also. Did you got my point? In the very earlier stage, while starting machine
Yes,
learning, I
yes
told
sir.
you that output we will also give and input we will also give. Then I will tell the model to
Predict.
predict. Okay, so in traditional programming, we will only give the input and the program itself will give you the output. But in here, we will also give the input and output also.
Yes.
Okay, to make the model. Did you got my point?
Yes sir.
Okay, so now what will happen? So x train x test, y train y test. So these are the split we have splitted. Okay, splitted means uh, X will split into train data, X test data, Y. So output will also have train and test percentage. Okay, so how you want to split, how you want to X Y you want to split. So test size is 0.30. 0.30 means 30%. So if you write 40 in here, so what it will happen, the test size will take 40% as the testing. So for training the data, it will take only. Uh, so can you tell me 150 of 30%? Can you tell me how many? Quickly tell me how much. Tell me.
45.
Okay, 45.
45.
So 45 flowers will kept as a test size. Test size means so we will test. Oh, these are model. We have to making list of 150 minus 45 105 flowers will be used as a training the data set. We will test that data set, or we'll check whether this value is whether if we put these three value four values, whether it is correctly predicting the model species or not. Okay, so now this is this line will use in many times, this splitting. Okay, train and test data set. Okay, so now will run. So it is splitted 30%. This data set is splitted. Okay, so I means to say 45 flowers will go into this data set, and for training we have like 105 flower. Why we are taking 30%, not 50-50? Why? Can you tell me? Actually, what happened if I told you to see some flowers? Okay, so I will give you many flowers so that you can predict the next 30 that you easily. So if I have 100 flowers, did I will I if I tell you see this 20 flower, then predict the 80 flower, will it be difficult? This will be difficult for you now. So if I give you 20 flowers, based upon your knowledge of this of that 20 flowers, I will tell you that you just predict. You just say the remaining 80 ones. Just tell me which class this belongs to. You will find it difficult now because you don't have too much of information. But if you quickly learn about 80 flowers, let's say, so race 20, you have a bit of knowledge now, because 80 flowers you have known. Okay, so then you can easily predict. Did you got my point? So that's why in training phase we will fit like 70-80%. Okay, in just testing phase we are just taking 20-30%. Okay, so that's why. So now we will bring logistic regression. Very simple. So from sklearn dot linear model, import just logistic regression, just import and put it in a model, in a variable called model. Okay, just you run this. Very simple. Okay, very simple. Okay, did you want to see this library? It's very long. I think this one. Okay, this is the code behind your. I think sklearn. Yes, yes. Did you see? You are calling this kind of large function. It's like 2,276 lines of codes in this just one uh, one just importing. Just you write import logistic regression. This code will work for you. This code will work for you.
Sir,
So if tell me.
sir, sklearn is a library or logical regression is a library?
Actually, sklearn is the library. It's a logistic regression is the kind of a part
Function.
function, you can say function. Yes,
Okay, sir.
it's a library. Okay. Okay, define kind of library you have. Inside that library, you will find many functions. Okay. Okay. Now we will run this. It is run. So now we will this data we have na x train. Oh yeah, x train we some declare some x test. So we'll feed this x train. Now we'll train the model. So in here we'll just train the model. So what we will do, we will put this. Okay, we will put these two variable into our model. In here we are just model dot fit, and this is the syntax. Okay, it's just run. Okay, so now logistic regression is it's done. It's the training phase is done. Now how to get the performance of the training? Okay, so if you run this, so you will get the it's like 95.55. Okay, so and again now next go to in here we are importing k neighbors classifier. Okay, so knn. Okay, if we run this again, we will run accuracy if we run. So it's like 95.55%. Okay, 95.55%. Okay, so next we will put decision tree. So we'll run again decision tree. So run decision tree will run 95.55. Okay, so why it is coming all the as a 95.55%? Is it wrong? Did you do some mistake? Now it's okay. Okay, actually I was not running this thing actually. Okay, now after this you have done 95. Actually you have to run this first. Okay, okay, and then you just run this. Then you have to run this. Did you get my point? What I'm doing? Okay, this is the score. Okay, so just ask ChatGPT. Okay, after if you are still confused, then you can just tell me. Okay, okay, just we are done the training phase. Okay, now we are not testing. So in the next class, maybe if I take, then I will show you. But if I don't get, sir will show you. Okay. Okay, thank you. Did you got my this iris dataset analysis, this classification, this notebook, everyone?
Yes, sir.
Okay, then okay, just go through and practice. You will get many examples regarding this iris dataset. You will get many examples. So this is the basic dataset that you will use in every course that will start from this dataset only. After that, you will go more difficult dataset. So this is a very renowned dataset that is, I think, collected by this British scientist. I think, I don't know, but it is a very famous dataset. You will find many examples regarding this. So it's kind of hello world program for this machine learning. Okay, this dataset actually. Okay, thank you. Okay, bye then. If you have any doubt, just leave it in group chat. Okay, after practicing, just go